Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
Okay, good afternoon, everyone. Just to let you know that first, I have to again open the lecture recordings before I start. Yeah. Yeah, just to let you know that first, I changed my consultation time because some of you mentioned you are going to have corporate accounting right at the same time of the consultation time I previously proposed. So that's why I changed that to 2 to 3 p.m. Wednesday. By that time, I think your corporate accounting course will finish, and then another hour on Friday, so that I can spread this consultation across 2 days, right, for your convenience. So second of all, just a reminder that a trial quiz will be open from 3 p.m. today, and it will last for 24 hours until 3 p.m. Tomorrow, Saturday. Right, so where you can find the trial quiz is here. So you go to the Pearson MyLab accounting section, and then I think if you haven't done so, then you have to do this first. So there's a student privacy notice and a consent. So you have to click yes, right, agree the privacy agreement before you can see the quiz. So once you've done that, then you can click the online quiz right here. Click this link, and then open a new window. So currently, because it hasn't reached 3 p.m. yet, so that's why you can't see the quiz. But what you can see here is I put an exercise there for you, which is learn how to use MyLab accounting. So there are some questions, simple questions there, and you can try to practice them as well. The purpose of having this exercise is to let you guys know how you can use the system, right? Say, for example, in the future quiz, you may have multiple choice questions, you may have fill-in questions, you may have short answer questions, right? So by practicing some exercise here, you will learn how to use your laptop, your desktop, right, to answer those questions of different types, right? So that's the purpose I put the link here. So the link will be there forever, right? Whenever you want to have a go and to get familiar with how to use MyLab accounting to answer questions from your own laptop computer, then you can feel free to do it. As I said, by 3 p.m. At 3 p.m. today, you will see another link, which is a trial quiz, right? So you can start doing the quiz. There are only a few questions there. So again, just to let you know, just want to let you have a good understanding of how the quiz looks like. But the formal first online quiz will be in week 4, right? From 3 p.m. Friday up to 3 p.m. Saturday that week. Okay. Are you clear with this? Yeah? Okay, good. So that's the first two things I would like to mention before we start this week's lecture. So now let's look at So last week you learned some basics about management accounting, including the cost concepts, right? Fixed cost, variable cost, and how to group different types of cost. So this week we, go a step further. We look at actually how those different costs behave, right? So why we want to know that? Because if we, just like a human being, right? If we understand how a person behaves, what are his or her characteristics, then we can get, we can have better relationship with him or her, right? Because we know him or her in details. So similar here. So if we can understand how cost behavior, a certain type of cost behave, right? Then we can, with that behavior in mind, we can predict how that cost will behave in the future, right? So we can make cost estimation, prediction, right, for the future, which is important, right? Which is important for management accounting. Right, so that's why this week we are going to talk about those. So that's the first bit of the lecture. So in particular, we are going to talk about linear cost behavior and non-linear cost behavior. I will explain in details what's the difference between them as we go through the lecture slides. And the second part, we are going to look at a particular analysis commonly used by organizations. Right? As I mentioned last week, I did research with some of the companies. I think most of them use this analysis, CVP analysis. So it's cost, right? C represents cost, V volume, and P profits, right? By using this analysis, we can understand how many units the company needs to sell in order to be safe, right? In order to, if not making a profit, but at least, stand by there, right? So that's the primary purpose of doing this analysis. But of course, this analysis can be extended, right, by including, target profit, sensitivity analysis, and a mix of sales. So again, I will explain details when we go through the lecture slides. So now let's look at the first bit, cost behavior, right? So what's cost behavior? Right? So if you live off campus, if you want to come to university, then, what do you normally do? By bike, by car, by bus, right? So a certain behavior a certain way of going to uni that you choose is kind of behavior, right? Similar here. So it's determining cost behavior determines how costs change with respect to changes in some activity. So if we are talking about manufacturing firm, then cost behavior means how a particular cost will change, right, when the total number of units made changes. Right? Different types of costs, they may behave different. Right? So that's why as you will notice, that we are going to have different types of cost behaviors. And as I said, why we need to understand cost behavior? Because we want to make predictions, right, about the same cost for the future, for future planning purpose. Right? So the first common cost behavior, typical classic cost behavior, is linear cost behavior. So linear, right, as you can see from the name. So if a cost is linear, then it means it will always move along a straight line. Right? It can be a line going upwards. It can be a line, it can be a horizontal line. Right? It can be, a combination of, a combination of them. So as you can see, I'll just quickly show you how it looks like, right? So as you can see here, so this is one type of fixed cost. So if you can see the graph, right, when the total number of units made increase from 0 to whatever, 800, 700, you can see that, the cost, this type of cost is moving along a horizontal line, right? So it's not here, it's not here, right? It's neither above the line or underneath the line. Rather, it's always on this line, on this blue line. Similar here, variable cost, a line going upwards, right? So when the total number of units made increases, then the cost, remember the total variable cost will also increase, but only in this line, right? And mixed function combination of fixed and variable cost, right? So that's what a linear cost means. So when the total number of units made changes, right, the cost will always move along a straight line. And there are three types, as I just mentioned to you: fixed cost, variable cost, and a mixed cost, right? So fixed cost, you know that the total figure will not change, right, no matter how many units you make changes, like the cost of purchasing equipment, right? If in a particular year, the company purchased the 3 equipments, machine tools, then that total cost figure is going to be fixed, right? Because in that particular year, the company will not purchase any equipment anymore, right? So no matter how many units are made by those 3 equipments, right, the cost of purchasing them are locked, right, the same. And in comparison to that, variable cost is different, right? Variable cost will change as the total number of units made changes. Like one good example is material, right, steel. So the more cars you make, then the more materials you will need to purchase, right? So which will increase the total cost figure. And so this is what you learned in last week's lecture. But this week we are going to introduce another cost, which is a combination of fixed and variable cost, right? Named mixed cost, right? So why is it called a mixed? As you can tell from the definition, right? It's a combination of both variable and fixed. So this cost is also sometimes very common, especially in the sales service industry. Like if you are an agent, right? Real estate agent, you're selling houses, then typically your compensation, the total money you receive, will have 2 parts. First, basic salary, right? So no matter you sell 100 houses or you don't sell any house at all, you'll always get that income, right? And in addition to that, they will also have a commission. Commission means if your sales is above a certain threshold, then you will get a commission, right? So that's kind of a bonus, extra money, the company gives to you, right? To reward you for your good performance, right? So in Australia, I think the different companies, they have different policies. But if a real estate agent earns $200,000 a year, I guess 60% of their salary, of their compensation will come from commissions, right? That may be different, right, in other countries. But in Australia, it looks like this. So the first part, the basic salary, that will not change, right, regarding the changes in sales, given that they are not going to change, so that's why they are fixed component, right, of the total compensation. And the commission, right, the more house you sell, then the higher it is. So that's why commission is a variable component of the real estate agents' income. So that's why we say that type of cost is the mixed cost. So because we are doing cost accounting, right? So we need to represent, or we need to describe those cost behaviors, linear cost behaviors, in a mathematical form. Why? Because otherwise, if we just talk about them and unable to convert them to numbers, then why accountants are there, right? So one of the jobs of accountants is to convert those abstract language into mathematical terms. So that's why we introduce a linear cost function, right? It's just like the linear equation you learned in your high school. So y is a dependent variable, right, equals a. A, remember, is the intercept, right, in mathematical terms. Plus b is the coefficient of the slope, right? X is the independent variable. So I think you guys should be very familiar with the mathematical equation here. So we are borrowing that equation to represent or estimate a certain cost, right? So that's why the left-hand side y, the item that we are going to estimate for, right, normally represents, right, the cost, right, we are interested in, right? So if we want to know or predict or estimate the total manufacturing cost, right, then Y, then the manufacturing cost should appear on the left-hand side of the equation. So A, as you can, sorry, maybe let's talk about X first, right? So X is the cost driver, right? We use X to represent the production volume of the company, right? So which means X can change, right? X will change, right, depending on a certain stage of the manufacturing process. And remember, if we use the variable cost per unit times the total number of units made, so that will give us a total cost figure, right? Have a guess that a total cost figure is variable or fixed? Variable, because if X keeps on changing, then the product of these two, right, should always change, should also change accordingly, right? So that's why B times X will give us the total variable cost, right? And there's one more item in the equation, which is A. A, in mathematical terms, is a fixed cost. Sorry, in mathematical terms, is the intercept, right? Intercept means it has no direct relationship with Y. With Y, right? So in other words, no matter how X changes, there's no effect on A, right? So in that case, what do you think of A? In cost terms, it represents fixed cost, right? Remember the definition of fixed cost, right? The total figure A will not change no matter how X, right, the production volume changes, right? So that's why A represents fixed cost in accounting language. So we use this equation to estimate a certain cost that we are interested in. So I just show you this, guys. I just show you guys, right? This is the fixed cost function, right? Because no matter how many units made changes, right, the figure is always the same. The total figure is always the same, right? And this is variable cost, right, in comparison. The more units you make, then the total cost of this type will be. And this is, have a guess? What's this? It's a mixed cost function. Why? Because as you can see here, so even if the company does not make any products anymore, if the company doesn't make any products at all, right, the company still has a cost there, and that cost will not change. Right, even if you make 100 units, right, that cost is still there, right? So that's why it has a fixed component. But at the same time, when the company starts to make products, then the total cost will increase. Having said that, right, the original $800 still remain the same. It's just that the second component, right, the second type of cost will increase, right, which is the total variable cost, right? So that's why if you combine the variable cost function and the fixed cost function, so that will give you the yellow line, which is a mixed cost function, right? And so it's very important in everyday operations, right? Management accountants identify fixed and variable cost. But sometimes caution needs to be taken. So first of all, whether a particular cost is variable or fixed, right, depending on the cost objects, right, for which item we are trying to estimate the cost for, right? The same cost may be a fixed cost, maybe a variable cost, depending on which item we are trying to estimate the cost. And the second, time horizon, right? So the longer the manufacturing process it is, then most likely, right, the cost behavior will change, right? I give you one example here. Let's talk about the equipment, right? Remember, we talked about equipment in one of the examples I used before, and for that cost, right? You guys know that it should be a fixed cost, right? But remember, machines, equipments, right? They do have a useful life. So the longer you use it, then the more likely they will be broken, right? Not a functionable. So if you use a machine for 10 years, So obviously, the efficiency, the functionality of the machine will decrease, right? So which means if the company still want to make 100 cars, right, the company may need to purchase another equipment, right? So therefore, the total cost of equipment will increase, right? So it's not a fixed anymore, right? So that's one good example. Why? We need to consider time horizon, right? Before we can say definitely, right, it's a fixed cost or variable cost. And the third, we also need to pay attention to relevant range, right? So why? Another example here. So if we are talking about a snowboard manufacturer, right, making snowboards used for skiing, so you can see from the graph that when the total number of units made is between 0 to 20,000, you can see the labor cost per unit increase or decrease. So when the company is making a certain number of units that falls below 0 to 20,000, you can see the slope becomes flatter and flatter, right? It means the labor cost for making one additional unit, right, within this range actually decrease. Why? So now we are doing management accounting, right? It's always relating to practice, right? So the figures you see, the numbers you see should make sense, right? Making sense means they have to be realistic, right? Representing what's really happening within the company's operation, right? Think about it. If you start making products, right? Some of the employees, when the first time making the first unit, it always takes more time, right? But as they keep on making the same products, their efficiency will increase, right? Because now they get as they make more and more units, they become more and more familiar with how they should do it. So therefore, the efficiency increase, which will reduce the labor, the timing, right? The time of making a similar unit, right? So that's why it will decrease. Labor cost per unit will decrease as the total number of units made increases. However, when it reach to 20,000 units, then the efficiency right will remain the same, right? Because at a certain level, you reach your highest potential, right? It's just like a soccer player. When they first play soccer, they keep on increasing, but when they become 30 years or late 20s, so they reach the highest level. Right? After 30s, their skills start to drop, right? So this is actually resembles, the 30s, late 20s of a soccer player, where their potential, their efficiency become constant. So that's why you can see that it's a straight line, it's a linear line, which means the labor cost per unit, right? The additional labor cost for making one additional unit is always the same. Right? And if you look at the third part here, maybe it's 65,000. When the total number of units made is beyond 65,000, you can see it requires higher and higher labor cost to make one additional unit because the slope is become steeper and steeper. Why? So what's the reason behind that? So we are human beings, right? So we are not machines. So as the more hours, the longer you work in a day, then the more tired you are. Yeah, you are right? So when people become tired, when workers become tired, then they start to slow down their, manufacturing process, right? So that's why longer is likely to take for making the same unit, right? So that's why the labor cost per unit increase, right? When the company, start to make more than 65,000 units, right? So as you can see here, when we are talking about cost, right, whether it's variable, it's fixed, really depending on, within which range we are talking about, right? So if the range is between 20,000 to 65,000, then it's a linear cost, right? But if it's out of that range, either, the first part or the third part. It's not a linear cost anymore, right? Rather, it's a curve. So that's why, rather than when we are saying a cost is fixed or variable, always need to be careful, right? What's the relevant range we are talking about, right? So that's the idea. So if you understand these basic concepts, linear cost, cost function, how we estimate cost, then we can talk about the particular method you can use, right, to estimate the cost function. So in management accounting, we have 4 methods to do that. Industrial, conference, account analysis, but those 3 methods are not the focus of the course. Rather, we focus on the 4th method, which is quantitative analysis, right? So including the high-low method and a regression analysis. But having said that, right, this does not necessarily mean that if we choose to use one method, then the other methods cannot be used. No, that's not true, right? We can use a combination of different methods to estimate cost function. It's up to the company, right? But of course, if you use more methods, then the more expensive it is, right? But this, as I said, in this course, we're focusing on the 4th method, right? High-low method and regression analysis. So now let's look at them. So for quantitative analysis, it's a formal mathematical method to estimate a cost function using data. So what we are doing here is, remember, one function of management accounting is to help the company plan for the future, right? How can we do that? Should we just, should the managers just sit together and then, do a brainstorming? They come up with the numbers? No, right? We need to rely on something, right? Which is data. So how a company performed in similar years in the past, right? Or in the last year, how our competitors, right, performed. And with those information, right, we can borrow those information to predict for the company's future performance, right? Because the data comes from the same company or comes from very similar companies. So they give a good indication for what's going to happen in the future. So that's why we need the data, right, for estimating cost function. But the reality is we have different types of data. So one type of data is called time series data. And the other one is cross-sectional. So I share one good way to remember these 2 types of data. So time series, it means it relates to timing, right? So in fact, this type of data means, refer to those data that are collected across time, right? So what's the cost figure for the company in the past 5 years, right? So if the company collect the data for the past 5 years from their own company, then those set of data is called time series data, right? Because those data span across different years. And differently, a cross-sectional data means, we collect data, right, for the same year, for the same time, but from many different companies, right? It's across different companies, right? Across different sectors, for example. So both data can be used for the company's analysis, right? But I guess most companies will rely on the time series data because due to competition, I think it's hardly, right? It's very difficult for the company to collect data from their competitors, right? Unless, there's a regulation there asking all the companies to publish their data on their website or whatever, right? So using quantitative analysis, right, estimating cost function based on past data. Given that we are doing quantitative analysis, right, we are predicting the future with some experience, with some past data. So therefore, the results are relatively objective compared to other methods, right? So this is the steps you can use, right, to estimate a cost function using high-low method. So there are two methods, remember, high-low method and the regression method. So for the high-low method, first step, we need to choose the dependent variable, right? Dependent variable is the cost the cost to be predicted, right? So for which cost we are trying to estimate here, right? So choose the dependent variable, and then identify the independent variable. So what's the cost driver? So what's the likely item, the changes of which will lead to a change in the cost we are trying to predict, right? So if you can identify that causal relationship, then we should be able to find the independent variable or cost driver. So once you identify dependent, independent variable, then we can collect data on them, right? So go back to the company's financial reports, right, prepared in previous years, and then look specifically at the numbers, accounting numbers for those two variables, and then plot those data, right? After you finish plotting the data, then you should be able to get a cost function, right? And in the end, don't forget to evaluate the reliability of the estimated cost function. After all, the cost function is an estimated one, right? So it helps us to predict the cost in the future. But the future is always uncertain. So that's why, the actual cost may vary, may be different from what we predict. So that's why we need to evaluate the reliability of the cost function. Whether the cost function can reliably help us, estimate the cost. There are some, mechanisms, some steps you need to follow in terms of evaluating the reliability, right? But we will discuss in the lecture problem. So now let's look at the lecture problem. So for this company, it's a restaurant. And there are some revenue and cost figures given. So the data from January, December up to December has been given, right? So the question is, use the high-low method to compute the cost function. So relating advertising cost and the revenue. So remember the first step, identify the dependent variable. So what do you think? What's the dependent variable you want to see here? Revenue. Why you want to see revenue as the dependent variable? So why you don't put advertising cost here? So yes, cost function, right, primarily help us estimate cost. Right? But we can also use the cost function to estimate revenue. Right? Maybe we shouldn't call it a cost function, but a revenue function. But the idea is the same, right? We identify the cost driver for revenue, and then do some analysis, right, from there. So think about it. If you are the manager, and of course you want to make money, right, for your business, but even before you start your business, the key question is how much cost we should invest, right? So that's why advertising cost should be an independent variable, right? Because as a manager, we always want to know with a certain amount of money, like advertising expense invested, so what's the return associated with that, right? So that's why you put a revenue as a dependent variable and the advertising cost as an independent variable. After that, you need to collect data, but we don't need to do that. All the data are given. But what we really need to do next is plot the data, right? Put the data on a diagram. So that's what I mean by plot. So put the data together in a diagram. It's a high-low method, which means you need to identify the highest and the lowest point, right? So I think attention should be taken here. So when we are talking about the highest and lowest point, we are referring to only independent variable, right? So if you look at the independent variable, which is advertising cost, what's the lowest point? 1,000, right? So look at this column here. 1,000 is the smallest number, right? But pay attention here. If you look at the revenue figure, which is the lowest figure, in which month the revenue is lowest? Isn't it September? You see, they didn't match, right? The lowest number for revenue, dependent variable and independent variable, they don't match. So that's why I caution you guys that we should always use the lowest point for independent variable, right? When you are using high-low method. So that's very important. The highest point is 4,000, right? Still, we need to focus on the independent variable. So therefore, the highest point is October, right? It's in October, and then the lowest point is in July, right? And then you draw those two points. You plot those 2 points on the graph. So for the lowest point, when advertising cost is 1,000, then the revenue will be 55,000, right? So that's the lowest point. So when the company increased the advertising cost to 4,000, then the expected revenue, the actual revenue, right? Because it's past 12 months, is 80,000. So this is the highest point. So now, if you look at the graph, we have lowest point and highest point, and then we connect them through a linear line, straight line, right? So that line is the cost function, right? Estimated cost function. So that's how you use high-low method, right, to plot the data and then have a graphical representation of the estimated cost function. But that's not enough, right? Because we are doing calculations, we are doing the cost. So we also need to use also need a mathematical representation of the cost function, right? So you learned mathematics. So how can we get the slope of this line? Using the vertical distance between the lowest and the highest point, right? So 80,000 minus 55,000 divided by the vertical distance, x, right, which is calculated as the distance between the lowest and the highest point. 4,000, minus 1,000. So that's the slope of coefficient, B, right, which is a variable cost per unit, right, remember? So now we have the variable cost rate, which is $8.33, right? $8.33. So now we are close to the answer, because now we got a B. So Y equals A plus B times X. Y, remember, is revenue. A, still there. Fixed cost we are trying to estimate. Plus 8.33 times advertising cost. Right? So now I think in order to get the estimated cost function, right, we just need to solve A. So how can we solve A? We can just choose either the highest or lowest point and then plug the numbers into the formula. So if you choose the highest point, then 80,000, right, which is revenue, when advertising cost is 4,000. Right? You can easily solve A, which is $46,680. Right? So that means the estimated cost function looks like revenue plus. So revenue equals 46,680 plus 8.33 times advertising cost, right? So that's the estimated cost function. But if you like, you can also use the lowest point, right? Because just now we used the highest point, right? You can also use the lowest point. Right? You should be able to get a very similar number for A. So that's how you use. So that's how you use high-low method to estimate the cost function. So remember, there are two methods we can use to estimate a cost function. Right? We just talked about the high-low method. So there's another method, which is the regression method. Right? Some of you may ask why we come up with two methods. So there must be some issues or weakness of the high-low method. Right? Can you imagine what are the problems of using high-low method? Can you still recall the data set? For how many months we have the data? 12 months. But how many months data we use? Just 2. Do you think that's reliable enough? Probably not, right? We just look at the highest, lowest, that's it. How about other data? We entirely ignore other data, right? So actually that's the problem of high-low method, right? The results may not be that accurate, right? Because we intentionally ignore other data, right? Which should also have predictive power for future cost, right? And so one way to address this is, so if the highest, either the highest, if any one of them, the highest or lowest point, right, looks like outlier, looks like a stranger, right? Stranger means if other, stranger means these data are very far away from those data, right, obtained from other months, right? So, for example, if from January to November, electricity expense seems to be around $10,000, and for December, right, it's extremely high, maybe $25,000 or even $50,000. Then that $50,000, $25,000 is an outlier, right? It's very far away from the average of the monthly cost, right? So one way to get away from this is, instead of choosing the December figure, right, we may need to choose another more representative figure, right? Of course, the highest number among that available set, right? So that's one way to get away from this, but still using high-low method. So another method is, right, as you can imagine, it's regression analysis, right? So what's the regression analysis? So regression analysis is a statistical method, right, to estimate A and B, and plus one residual item in the cost equation, right? So this statistic analysis focus on is putting all the data, right, together, group all the data together, right? With all the data, right, in it can help you estimate an average. It's not an exact average, mathematical average, but it gives you, a linear line, right, that can reliably, right, represent all the data, right? So that's what a regression analysis is doing. For this course, you don't necessarily need to know how to use it, but what you do need to know is how to interpret the figures, right, generated by the statistical analysis. I will show you, so we will discuss a second lecture problem where you can see what are the figures that are given by the, what are the outcomes or results are given by using the software. Right? But before we do that, I would like to highlight some other points. Right? So this I have already mentioned. Right? Incorporate more than one independent variable. Right? Have more data in it. Procedures are available to test the assumptions of the regression analysis. Before you use statistic analysis, right? You need to, because the statistic software has some assumptions. But the good thing is, if you use the software, right, to do this analysis, that software always allows you to test the assumptions, right? But only when the assumptions are met, then you can use regression analysis. Otherwise, you cannot use it. For example, if you want to use a regression analysis, one typical assumption is the data is normally distributed, right? Normally distributed means looks like this, right? Normally distributed. It has the lowest point and the highest point, but most of the data are crowded in the middle. Right? But if the data looks like this, right, skewed towards the right or skewed towards the left, then you can't use the regression analysis, right? Because the data by itself is strange, right? Because most data is either crowded towards the left or the right, right? So which will not give us a reliable prediction if the data looks like this. So the regression analysis also includes a residual item, right? Residual means, remember the cost equation, right? We just mentioned A plus B times X, right? So remember, this is a cost function, but only estimated cost function. So when we use this cost function to predict a cost, right? Say for example, we use this function and predict a cost of $80, but when the actual cost is $80, right? There's a variation there, right? So how can we count a variation? High-low method doesn't allow us to do that, but a regression analysis allows us to do that, right? Because it has a residual term. So any unexplained variations, right, will be included in that residual term, right? So I think that's another reason why regression analysis is superior. So after you got an estimated cost function using either high-low method or regression method, the last step is always to evaluate the cost function, the reliability of the cost function, right? Whether the cost function we have on hand is reliable, right? It's making sense in economic terms, right? So there are three criteria you need to check. So first of all, economic plausibility, right? So in other words, whether the relationship between X and Y making sense economically, right? Goodness of fit means, whether, so goodness of fit measures the causality of X and Y, right? So if you like, economic plausibility tells us the correlation between X and Y. So when X increase, Y also increase. But this does not necessarily tell us whether X is a cause of Y, whether the changes of X is a cause of Y. But goodness of fit, right, give us an indication on that. So if you use regression analysis, then one of the outcomes you will see is R squared, right? R squared allows us to check the cost function's goodness of fit. So the benchmark is 0.3. So if they're using regression analysis, you can see if the R squared is higher than 0.3, then it meets this criteria. Right? We can see, the cost function has a very good goodness of fit. And the last one is significance of independent variable. So now we know that there's a correlation between X and Y, and we know that X causes Y. X is a cause of Y. But the next question is, what's the significance? How significant of the change of the impact of X on Y, right? So that's why we need to, also check this item. So we ask, is the coefficient of the independent variable significant different from 0? If the answer is yes, then we can say, the independent variable has a significant impact on dependent variable. And if you use high-low method, right? After you plot the data points, you should look at the slope of the regression line and the scatter. How scattered the data points are around the line, right? Only when you are using high-low method. But now let's look at. So if you use the regression analysis, check the t-values, right? Provided by the statistics software. So now let's look at the second problem. So hopefully after that you will have a clear understanding of what I just said. I know it's very abstract, right, when just saying, but now let's do the problem. So lecture problem 2.2. So the same data set as what you got for the first problem. And what's new here in this question is instead of using high-low method, right, this question used regression analysis, right? And as I said, you don't need to know how to use the software, right? You just need to know how to interpret the results. So that's the results given here. So you can see you have multiple R squared, right? Intercept and the coefficient standard error for X for the independent variable. And in addition, if you use the software analysis, in your computer, it will also show you the graph of the estimated cost function, right? So all this information data will be given, right, by the software and also in the exam. So what you need to do is draw some of the numbers, right, and try to derive the estimated cost function. So how can we do that? Remember, the cost function is y equals a plus b times x, right? So y is the revenue, a is the fixed cost. So we need to look at the intercept, right? Because in mathematical terms, a represents the intercept, right? Although in accounting language, it represents fixed cost. So it's 39197.08, right? Plus b. Can we find a b? B is the slope of the line, right, which is the coefficient for the independent variable. So coefficient for the independent variable x is 8759 times advertising cost. Right? So that's how you get this equation, estimated cost function from the data that are available. We haven't finished yet. Why? Because we are also required to evaluate, right, the cost function. That's important because if we make the decision that the cost function is not reliable, then we cannot use it, right, for predicting future cost. So only when a cost function is reliable, then we can use them. So as you know, we need to check three things. Economic plausibility, right? So whether the relationship between X and Y, so in this case, advertising cost and the revenue making economic sense, right, or not. So how to check that? You just check the sign of the slope of coefficient. It's positive, so which means the more advertising cost you spend, then it seems like you are going to get more revenue. Does that make sense in economic terms? Yes, of course, right? More investment, more returns, higher returns, right? So that's why, yes, it's making economic sense, right? And then next, goodness of fit. How can we check goodness of fit if we are using regression analysis? Check the R square. It's 0.656, which is greater than 0.3. Remember, 0.3 is the benchmark. So if it's higher than 0.3, then which means it has a goodness of fit. And finally, significance of the independent variable, right? Which stats we need to look at? T stats, right? So what a figure you find? 4 point, right? T stats for x variable, right? Not for intercept. 4.37, which is bigger than the T critical. How much is T critical? Is given, right? T critical is always given, right? Don't worry about that. You don't need to calculate it because it's always given. 2.22 or 3. Okay? So again, it also meets the third criteria, which is significance of the independent variable, right? So all the three criteria are met. Then we can say it's a reliable, right? But if you are using high-low method, you don't have, when you don't have stats, then can we still evaluate, right, the cost function? The answer is yes, right? So if you want to check economic plausibility, just need to, again, by looking at the line, you just check the, the correlation between x and y. So again, if you just look at the graph, you can see that advertising cost increases, right, which will lead to the increase in revenue, right, which again is making economic sense. But how to check the other two criteria? You just need to look at where the scatter, right, of the points around the line. So the closer all these points are to this straight line, then which means the line is relatively more reliable, right? Because remember, this line are these dot points represents the actual revenue, right, at a certain level of cost. And respective points, right, for a certain amount of advertising cost on the line represents, so this red points represents the estimated revenue, right? So the revenue estimated by the cost function. So you can see there's a distance, right, between the actual revenue and the estimated revenue. So that's normal because, given that we are using this line to just make a prediction, it's acceptable, right? If it has some, it has some errors. But the point is the error cannot that big, cannot be too big, right? Otherwise, if the points, if let's assume the actual revenue is here when the cost is 1,000, then it's going to be very far away, right, from the line. So which means in this case, the line is very good. It's not a very good, right, at predicting a certain item, right? So again, the point to summarize, the point here is if you are using a high-low method, always check how scattered, right, all the data are around the line. So if all the data are very close to the line, right, then it has, it meets the other two criteria, right? But if the data looks like this, then it can hardly meet the criteria. So if the data looks like, all the actual points are here, everywhere, then, the line is in the middle. So that's not the line that we like to see, right? So that's how you evaluate the cost function, right, using the two methods. Okay. So that's for this question. And how about let's have a 5 to 10 minutes break before we start. Hello.
regarding like we talk about time series data, right?
Yeah.
So in this, I want to know how accurate or how predictable it is because we're using the past data to predict the future.
Yeah, so that's why we need to check the reliability of the cost.
So that's why we do regression.
Yeah. Otherwise, if all the all the predictions are accurate, then why we then we are we are the god.
That's what I want.
Hello. Just give me a second. Yep. All right. So maybe let's resume. So just before the break, we talked about the estimated cost function, right? How to get that function, and how to use past data, right, to help us do that estimation. But bear in mind that sometimes if the data has problem, right, then the function, the cost function, will also have problem, right? So that's why. Normally, the more numbers you have, the more observations you have, the more years data you have, then the more reliable the cost function you estimated will be. Right? So try to collect as many data as possible. Right? And the second, because the world is uncertain, right? The world may change very fast. So if there are some major changes have occurred, then you have to consider. We have to take consideration of that change, right? The major change when estimating our cost function. Say for example, currently I know that there's a trade war between U.S. and China. So how that will affect our cost of manufacturing a certain product, right? We need to take consideration of that, right? By maybe incorporating maybe by increasing the tax. Right, cost relating to tax, right, into the cost function, something like that. Right, just give you one example. And the last, when we are using the data, so we have to be cautious that sometimes the data, different sets of data, different types of data may not be are not matching, right, in units. Say for example, on the left-hand side, the dependent variable maybe is a cost, right, only calculated or on a annual basis is a yearly figure. But on the right-hand side, the X, right, the cost driver, right, the cost driver is only estimated or is only calculated monthly. Then you can see that the units used for the dependent variable and the independent variable are not matching, right? So therefore, we have to convert the dependent variable to a monthly figure, right, before we can use those data to estimate cost function. Right? So these are the common problems, right? You need to be careful when estimating the cost function. So now let's move on to another type of cost, right? Nonlinear cost behavior, nonlinear cost, right? So you can see that you can see this graph. So it's not a linear, right? Because the cost we are trying to predict is not moving along a straight line, right? It's not a straight line, but it's a curve. Half of the curve facing downwards, right? So that's possible in everyday operations. So one good example is think about the cost of purchasing 1 kilogram of material. Sometimes, right, to encourage customer to make more purchases, right, the seller may discount the materials, right, discount the material price per kilogram, right, if the customer purchase a large quantity of material. Right? So that's why the more materials you purchase, then the likelihood that you will have a lower and lower cost, right, per kilogram material. Right? So that's why you can see the slope becomes flatter and flatter. Right? So that's one good reason why some cost may not behave linearly. Right? And another good example is step cost. So remember, we talked about relevant range, but out of the relevant range, a fixed cost may change, right? So as you can see from this graph here, within the first relevant range, the total fixed cost is the same, right? However, in the second part of the relevant range, maybe because the company need to purchase more equipment, right? So the total cost, right, increased, right? Similarly, in the third part of the relevant range, another one or two equipment need to be purchased, so which will further increase the total, right, fixed cost. So as you can see here, right, this cost behave like like steps, so that's why we call them step cost. So these are all good examples of non-linear cost. Right? But we are going to discuss more on a fourth type of non-linear cost, where we consider the effect of learning. Right? People learn when they are doing their jobs. Right? So that's why the cost associated with those workers may change. So why we need to consider the learning effect? Because it will have implications on labor cost, right? On other types of costs like materials. Because the more familiar, right, you make a product, then the less likely the worker will have issues, will incur some problems, right, when making those products, reducing the total amount of wastage, right, for materials. So that's why learning effect will not only affect labor cost, right, but also material cost sometimes. So this learning effect typically occurs when there are new products introduced in the production line, when the company implemented a new production method, right? So when the company has just recently hired some new employees, right? So these are the periods where learning effect is likely to occur. So when we are estimating cost, labor cost, and material cost, we do need to consider, right, those effects. So after the learning period, right, relevant cost, labor cost, and material cost will plateau, right, will become constant, like the one of the graph I show you, right. But in management accounting, we have two methods to count the learning effect. So one is a cumulative average learning model. The other one is incremental unit time learning model. So I will discuss two problems with you, right? And at the same time, I will introduce the idea of those two methods to you. So let's look at them. So lecture problem 2.3. So in this problem, we are using cumulative average time learning model. So under this model, what happens is, it assumes when the total number of units made doubled, then the average time needed for making each of unit will decrease by a certain percentage. So in this question, it's 75%. So how does that work? So let's do the questions. So it's given in the question that it takes 50 hours to make the first unit, right? So which means when making the first unit, it will take the company 50 hours, right? So when the total number of units doubled, when the company is making 2 units, right, the cumulative average time needed for making each of the 2 units will decrease by 75, a constant percentage, right? 75%. So similarly, when the company is making 4 units, then the time needed for making each of the units will decrease by 75%. So average time needed for making 2 units, right, times 75%. So that will give you 28.125 hours. So that's what it means by cumulative average time learning model. So whenever the total number of units made doubled from 1 to 2 or from 2 to 4, right, the average time needed for making each of the unit will decrease by 75%, right? Will decrease by a constant percentage, right? So then we can work out what's the total time needed. So the total time needed for making the first units, right, still 50 hours. So the total time needed for making 2 units, have a guess, is how much? How many hours? 37.5 times 2. Remember, this is the cumulative average time needed for making each unit. Given now the company is making 2 units, so you have to double that to get the total time, right, needed for making 2 units. So I think it's 75 hours. So do the same thing for 4th unit. So 28.125 times 4, right? So you can get 112 hours roughly. So that's cumulative average learning model. So we have a second model, which is the incremental unit time learning model. Right? So this method looks very similar to the first method, but they are different. So in this method, the assumption is whenever the total number of units made doubled, right, only the additional time, right, only the total time for making the second or the additional unit decreased by a constant percentage. So now it's not the average time, right, for making each unit, but the time, total time for making the additional unit. So in terms of calculations, so the time needed for making the first unit is still 50 hours. So if we times 50 by 75%, the same calculation, right? So I think you can still get 37.5 hours. But this is not the average time needed, right, for making each unit, but the time for making the second unit, right, only. So therefore, if you like, the total time needed for making the first unit is still 50, and the total time needed for making 2 units will be 50 plus, 37.5. So add up to 87.5 hours. So that's the difference here, right? So similarly, when the company is making 4 units, calculation is still the same. 75% of 37.5 hours, right? So that's 28 hours. But this is only the total time needed for making the 4th unit, right? So just bear that in mind. But up to now, I think you have a good understanding on the difference between cumulative average learning model and the incremental unit time learning model. But do you have any questions so far? Yeah, I guess you must have some doubts. How about the total time needed for making 3 units, right? So according to the theoretical definition, I think there's no way we can know that. Right? So that's why I don't know how to get it. But we can use another method, which is the formula method. Right? So we can use a formula here to help us work out the total number of hours needed, or the average hour needed, or the additional time needed for making the 3rd unit. So the equation is y equals a times x to the power of b, right? So what's y? If we are using cumulative time learning model, then y is the cumulative average time, right? Which is actually the number we want, right? What's a? Is the time for making the first unit, which is 50. X represents the number of units, right, the company is making. So if we want to know the cumulative average time when the company is making 3 units, then we put a 3, right, in the equation. B, which is the rate of learning, which is log percentage. In this case, is 75%, right, divided by log 2. So in the exam or in any questions, how can you calculate B? It's always the log learning percentage divided by log 2, right? So you don't need to understand why is that. I don't know. I don't understand either. It's just I got experience, right? Previous accountants give us this, share this experience with us. But just remember this formula. And then you do the calculation, you will get 31.69 hours. Right? So remember, we are talking about the cumulative average learning model. So therefore, this will be the cumulative average time needed for making each of the first 3 units. So therefore, if you times 3, right, that will give you the total time needed for making 3 units, which is 95 hours. Yeah. So you can still apply the same formula in the incremental unit learning model. So you will still get a 31.69 hours, but this time it's not the average time anymore, but the additional time needed for making the third unit only, right? So 31.69. Right? So therefore, the total time for making the first 3 units is the sum of 50 time needed for making the first unit, 37.5 time needed for making the second unit, and 31.69 time needed for making the third unit. So in total, it will take the company 119.19 hours for making, right, all of the first 3 units, right? So if you know the total time needed for making the first 3 units, and then use 119.19 hours times plus 28.12 hours, so you will get 147.315, right, hours. So that's how you do the calculation under the incremental unit learning model. So as you can see in the last column, you can, if you want, right, you can still calculate the average time, right, under incremental unit learning model. So what you need to do is to divide the total time by the total number of units made, right? So I will leave the calculation to you guys. So that's how you get the average time needed for making each of the units when the company is making a certain number of products. All right? Is that clear? So that's why when you have this type of question in the exam, always pay attention which model is assumed. Right? Different model will have different results. So let's go back to the lecture notes. So we talked about the incremental cumulative average learning model. So the next important, management accounting tool is CVP analysis, cost, volume, profit analysis, right? So some of you may ask why we put these 3 items together, because these 3 items are closely related to each other, right? For example, if there's a change in sales, right? If there's a change in total number of units sold, most likely, right, the company's total cost will be affected, right? So if you increase your sales, most likely your total profits will also, right, increase. So that's why, in reality, given that these 3 items have very close relationship, so that's why we put them together and then do some analysis to see whether the change in one of them, right, the sensitivity of the change in one of them, whether that will affect, right, the other 2 items. And in fact, these 3 items are very important, right, to the manager of the company, right? We want to know the sales. As manager of the company, we want to know the total cost in order to make those sales. And finally, we want to know how much money we can earn, right, by making those sales. So that's why, we need to focus on these 3 figures. But there are some assumptions similar to the regression analysis, right? Normal distribution assumption. So if we want to use CVP analysis, there are some assumptions, right, we need to make. Otherwise, we can't use them. So first of all, volume is the only revenue driver and a cost driver, right? So which means we assume, right, only volume can affect revenue and cost, which is not the case, right, in reality. But for simplicity, we just assume that if you want to use CVP analysis. Right? Second, cost can be separated into fixed and variable cost. So we don't use another cost grouping method, which, where we separate all the cost into fixed, direct, indirect cost, right? If you do that, then you can't use CVP analysis, right? Only when, we group all the costs, we separate all the costs into fixed and variable, then we can apply this analysis. And the third assumption, revenue and cost can be reliably determined, right? So that's easy to understand, right? So, but however, having said that, for some industries, it's really hard to estimate revenue. Say the high-tech company, right? Because the technology change very fast, so you never know how your customer will still buy your products in next year. So that's why for those companies, it's really hard to have a very good and reliable estimation on revenue. So probably CVP analysis is not right, very good for them. But for manufacturing company like automotive company make cars, I think most of the company use them because I did a research with one of them. I know that they use them, and although it's not that very accurate, but this can be used. This analysis can be used as a first screening, right, technique, right? Just to give the manager, the company, a rough idea, right? How many sales you need to make, right, in order to be safe. So we also need to assume the behavior, right, is the same. Cost behavior remain the same over a relevant range, right? So revenue costs are linear over the relevant range, right? Selling price, variable cost per unit, total fixed costs are constant, right, over the relevant range. And the total contribution margin is also linear, right? So basically linear assumption. We assume, right? If you want to use this analysis, we have to assume, right, all the costs are linear, right? Otherwise, we can't use it. So there are more assumptions. Sales equals production. All the units made, right? The company can sell all the units they make, which is normally not the case, right? Company either produce a single product or maintain a constant sales mix. So constant sales mix means sometimes, right, the company can make multiple products. Like BMW, right, they make one series, 3 series, X series. So, but that's okay. But the problem is, the key point is, if you want to use CVP analysis, you should assume, right, the percentage of sales for each model of car is the same. So if the company can sell 100 cars, so 50 of them must be, the 2 series model, right? 45 for the 3rd series model and 5% for the 4th model. And this sales percentage is always the same. Again, in reality, it's hardly like that, right? Because customers change their preference very quickly. Sometimes, in older years, people like the SUV, but now people realize that, it's too, right? It's too, it's very costly, right, to drive an SUV. Petrol is very expensive, right? And so so that's why nowadays, those car companies start to make the medium-sized SUV. It's kind of between the sedan and the SUV, right? Which is very popular these days. And finally, other factors. Uncertainty of cost and revenue estimates is ignored. Again, it relates to these points, right? Revenue and cost can be reliably estimated. And finally, other factors, labor productivity, technology will not change, right? So that's all the 8 assumptions behind CVP analysis, right? Although, although there are some problems with this CVP analysis, but again, it's a very budget and easy to use tool for a company to have a prediction on the total number of units sold, right, for their next years, for their future operations. And in order to use break-even analysis, we can use the equation method. We can also use contribution margin method. So I will discuss each of them in the next few seconds. But what's break-even analysis? So we mentioned the CVP analysis, right? So break-even analysis is one type of CVP analysis, right? So which assumes when the total number of revenue can cover the total number of cost, then how many units does the company need to sell, right? So that's break-even analysis. So, that's very important because we need to know the total number of units sold. Total number of units sold that can help the company cover all the cost, right? Once we have identified the number, then we can say that's the margin, that's the safe line. So we need to make sure, we need to take all the possible course of actions to ensure our sales is beyond that figure, right, in order to make a profit. Right? So that's why lots of companies use this CVP analysis, right? Because after they have determined the break-even point in units, then they can try to allocate the staff to different, right, to sell different types of products. So equation method. So on the equation method, what we need to do is we need to write down an equation. So the equation is, remember, how can we calculate profit? Using sales minus cost. So basically, we assume profit is 0, no cost, no profit, no loss. So that's the definition of break-even point, right? And then expand the equation. Total sales, how can we calculate it? We use the selling price per unit times the total number of units sold, right? And then minus total cost. Total cost, remember, we can separate them into fixed cost and a variable cost. So total variable cost equals variable cost per unit times total number of units sold. Remember, these two units are the same, right? We assume total number of units sold is the same as total number of units made, right? That's one assumption of CVP analysis. And then you make profit 0, right? So basically make operating income 0 here, right? Then you can, if you know selling price, fixed cost, and a variable cost per unit, then you can get the total number of units sold, right? So that's the safe line. So that's that figure is the break-even point, right, in units, right? For which the sales, for which the company always need to achieve. Otherwise, the company is going to make a loss. So that's the equation method. And sometimes you can use the shortcut, right? We call it contribution margin method, but essentially I think they are the same, right? The second method is the same as this method. So remember, the units sold, right, is the same. So we can, extract total number of units sold from the bracket. So that will be selling price minus variable cost per unit times total number of units sold, right? And minus fixed cost equals 0. So we move fixed cost to the left-hand side. It will look like this, right? So if you rearrange this formula, so total number of units sold then equals fixed cost divided by selling price minus variable cost. And we know that difference between selling price and the variable cost is contribution margin, right? So which means you can also calculate break-even point by straight away using dividing fixed cost, total fixed cost, by the contribution margin per unit, right? So that's exactly how we get this formula here for calculating break-even point, right? Derived from the first method, equation method. So that's why I said that essentially they are the same. Right? But sometimes the question given different on the different questions, the conditions may be different, right? In some questions, it doesn't tell you the selling price, variable cost per unit, but rather just give you a contribution margin figure. Then you probably need to use the second method to solve it, right? But essentially they are the same. So for graph method, I think it's not going to be tested, but it's still good to know how it works, right? But you can refer to the textbook page 135 for more illustration. So I'm not going to discuss it. It's not going to appear in the exam. So now let's look at lecture problem 2.5. So have a quick read for the question, right? So it's a break-even calculation question. So I'll just give you 10 to 20 seconds to have a quick read for this question. So there are some cost information, sales revenue given, right? So the question is, how many units must the company sell to break even? Answer this question using the equation method, contribution margin method. So if we use the equation method, so let X be the break-even points, right? The total number of units, the sale of which will make revenue and the total cost equal, right? So then we just using the formula here, right? Total sales minus total variable cost and minus total fixed cost equals 0. So expand this formula. Selling price per unit, $55 times X minus 25, which is the variable cost per unit, times X and minus total fixed cost. So X is 7,910 units. So if you want to use contribution margin method, you can straight away apply this formula here. Divide total fixed cost by contribution margin per unit, which is the difference between selling price and the variable cost per unit, right? Being $30 per unit. So you can still get break-even point in units. Right? So very straightforward, very easy. So as long as you understand the concept of break-even, then break-even point, then you should have no problem in solving this question, this type of question, right? However, the question may become complicated. Right? This type of question may become complicated in some scenarios. First, remember, break-even point occurs when profit is 0, no profit, no loss. But for some companies, right, avoiding a loss or getting no profit, no loss, right, is not their long-term goal. If the company keeps making no profit, even if there's no loss, then what's the point of continuing the business? Right? We are doing everything, but no gains. Why we do it? Why we keep on doing it? Maybe in the first 3 years it's okay, right? Because it just started, lots of cost. But starting from the 4th year, if we're still not making profits, then we need to think about whether we need to change our strategy or doing something else, right? So that's why sometimes starting from the first few years, after first few years, now the company wants to get the profits, right? So if the company want to lock a certain amount of profits, then what's the total number of units needs to be sold, right? So that will complicate. That's the extension of the break-even point analysis. But you can still apply the same method, right, to address this type of question, where you can treat profits just as another additional cost, right? Additional cost to be covered. So if you want to use the equation method, so instead of assuming, the right-hand side of the equation, 0, remember on the break-even point, we assume profit is 0. Here, you just put a profit figure in, right? Profit before tax. Just put a profit figure in here, and then, expand the left-hand side, right? Still using selling price per unit, right? Times units sold, and then minus variable cost per unit times number of units sold and minus fixed cost. Get a profit figure, right? And then you can get X equals, 14,389 units. So in other words, if the company want to get a profit before tax figure 194,000, then they have to sell this amount of units, right, to meet that target. Or if you want to use contribution margin method, so that's how you do it. So instead of just having fixed cost, right, in the numerator, you should also add the profit before tax, right, because we treat it as an additional cost that needs to be covered, and then divided by contribution margin per unit, right? So you can still get the total number of units need to be sold, right, in order to meet a certain target. But sometimes, right, if you are the owner of the business, if you are the owner of the business, right, you care about the actual money that is going to your pocket, right? So you look at a bank account and realize that, oh, actually we got a certain amount of money, right, coming to our bank account, and that money is always the profit after tax figure, right? So if you end up having profit after tax, right, in the question, then you should convert that number to profit before tax figure, right? Before you can, right, apply the CVP analysis. Remember, in the CVP analysis, the profit figure is always before tax figure, right? So if you are given profit after tax, so you need to use profit before tax. Sorry, you have to use profit after tax divided by 1 minus tax rate. Right? So how can we get this? Because, in Australia, India, China, I think all those countries, for every dollar revenue earned, right, by a company, right, some part of it, some of that revenue will be given to tax office. Okay? So if let's assume the company earned $100 in a particular year, right, before tax, then we have to give $30 to tax office if you have a business here in Australia. Because currently I think the company tax is 30%, right? But for small business, maybe for some small business, maybe 25%. But most companies still, I guess, still 30% tax rate, right? So profit after tax is $70, right? So if you are given profit after tax, then you have to convert that to profit before tax, right? Which is $100. So in other words, profit before tax minus 30% times profit before tax. That will give you profit after tax. So in order to know profit before tax, then we have to use profit after tax divided by 1 minus 30%, right? So that's how we get. So that's how we get a profit before tax. So using profit after tax divided by 1 minus tax rate. But I do want to let you know that there are some very few countries they don't have tax at all. So one good example is UAE, United Arab Emirates. It's a Middle East country, right? So a very rich country. So the government don't charge tax for their residents, which is good. Right? But most companies, most countries, they do have tax for the business operating within those countries. Yeah, so that's just the one, just the formula, right? We use if you are given profit after tax. Remember, we have to always convert profit after tax to profit before tax before we can use the CVP analysis. And CVP analysis, another type of CVP analysis is called a sensitivity analysis, right? So I tell you the experience. This engine service, U.S. engine service company. So what they did is, instead of just making one prediction, right? So they consider three scenarios when they are using CVP analysis. So they call them, the standard scenario, right? Basic scenario. So which is likely to occur, right, in next year. But at the same time, they also have another two scenario, which is the best and the worst scenario, right? So why some of you may ask why the company needs to estimate three scenarios? Because if the company only has one scenario, and then if the actual results turns different to that particular estimation, then the company will have problems, right? They don't have backup plans. However, if the company have considered all the possible scenarios and then propose a response, right? If each of the three scenarios occurs, then the company will be more safe, right? Because you will never know exactly what's going to happen in the future. So that's why for that company they prepare more, so that when the accident happens, they have enough time or they have enough preparation, right, to deal with the uncertainty. right? So that's why they always have 3 scenarios in their model, in their budget, whatever, accounting estimation, right? But in addition to that, it's not relevant to this, but in addition to that, these days, I'm still talking about that particular company. They also estimate the possibility of the occurrence of a particular scenario, right? So what's the possibility of, what's the possibility what's the possibility of the occurrence of the second scenario, right? 80%, 90%, or 10%, right? So there's a software called At Risk software. So basically, the company just put all the accounting numbers in and then click a button. Then the software will help you do the scenario analysis and also accompanied with the probability of occurrence for each scenario. Very easy to use. But I think the difficult part is collect data, because that company is a very big company, right? It has branches over lots of countries. So collecting reliable data and in a timely manner, right, in a accurate way from different branches, from different countries, is a big challenge for that company. So once they have got those data, just put those numbers into the software, right? Then they can get the estimation. So technology nowadays makes our life easier. So that's the sensitivity analysis. So the last type of CVP analysis I'm going to introduce to you is the sales mix, right? Effects of sales mix. So where, previously, right, for the previous different types of CVP analysis we just talked about, the assumption is the company is only selling and making one product, right? But it's not the case in reality, where the company is actually making multiple products, right? So under that scenario, can we still apply CVP analysis, or specifically break-even point analysis? The answer is yes, but there are some differences. So let's look at the last lecture problem. So it's about sales mix and how we calculate the break-even point under this scenario. So have a quick read for this question. So the company is making 2 products, right? More than one product. The company is making 2 products. And the selling price, variable cost per unit, expected sales, fixed costs are given. So the question is, calculate the break-even point. So in other words, how many units of A, and at the same time, how many units of B need to be sold in order for the company to break even? Making no profit, but no loss, neither. So again, we can use the equation method. So under the equation method, what we can do here is we let B, the number of units of B, needs to be sold in order for the company to break even, right? And remember, whenever the company sell 48,000 of B, how many A they can sell? 72,000, right? So therefore, you can figure out the relationship between A and B in terms of sales. So the results is whenever there are 3 units of A sold, right, the company will sell 2 units of B. And this relationship is always the same, right? So that's the assumption we need to make before we use CVP analysis. So which means whenever the company sells 1 unit of B, then they will sell, right, 1.5 B. They will sell, 1.5 of A, right? So therefore, you got the relationship between A and B. So that's important. So once you figure out the relationship, you can, go to the, equation. So we use the sales, right? Total sales. This one here. Total sales minus the variable cost and minus fixed cost. So total sales total number of units A. How many units of A are sold? It's 1.5 B, right? And then times the selling price for A, which is 0.7, right? So that's the total sales, expected sales revenue for A. And for B, it's B times selling price of B, right? So that's the total sales revenue. And minus the variable cost, total variable cost, 1.5B times, what's the variable cost for 1 unit of A? 0.5, and then minus B times total number of variable cost per unit of B. And minus total fixed cost, right, 55,000. So you get 0 for that. All right, you can solve B. B equals 100,000 units of A. So 100,000 units. Then A will be 1.5 of that, which is 150,000 units. So therefore, the break-even point is 250,000 units. But pay attention here. If you have a sales mix question, you not only need the total number of units sold to break even, but also you need to break that figure down to the total number of units for A and B. Right? So which means you need 3 figures actually, 3 break-even points. One is the total figure, second, the figure for B, and then third, the figure for A. Right? Always need 3 numbers when you have sales mix question. So that's the equation method. And we can also use the contribution margin method. Remember the formula for contribution margin? We have to use fixed cost divided by contribution margin per unit. But now remember, the company is selling two types of products. So you can't use contribution margin for each of the units, but rather you have to average the contribution margin for A and B. So that's why we call it weighted contribution margin per unit, right? So fixed cost is given. So I think the key point is to get weighted average contribution margin per unit. How to do it? We need to use 72, right, divided by 120. Sorry, basically, you can think about it this way. So among the total number of units sold, so let's assume when there are 72,000 units of A are sold, then how many units of B will be sold? 48,000, right? So using the total number of units sold for A divided by the total number of units sold, so you will get 60%. You do the same thing for B. Whenever the company sells 48,000 units, then they are expected to sell another 72,000 of unit A. So that will give you 40%, right? So you can calculate weighted average contribution margin based on these 2 figures. So 60% times the contribution margin for unit A, and then 40% times contribution margin of unit B, right? So that's how you calculate the weighted contribution margin, right, per unit, considering both A and B. So just put the figures in, then you can get 22 cents, right? And then you put these 22 cents back into the formula. And don't forget to include the fixed cost. So fixed cost divided by the contribution margin per unit, then you can still get 250,000 units. Again, if you end up there, then you will not get 4 marks. You need another 2 figures, one for A and one for B. So 60% of that will give you A, right? And 40% of that will give you B. So in the end, these are the 3 numbers you need. Yeah? So that's this question. So I think that's the end of the question. Right? So basically this week, to summarize, in this week we'll learn a linear cost, non-linear cost, and how to use CVP analysis. Different types of CVP analysis, right? Break-even analysis, when the company wants to earn a profit, sales mix, right? When we, include tax in the calculation. So, yeah, so that's the end of the lecture. And don't forget to do your trial, please, right?